Hi, I just wanted to say thank you so much for giving me the opportunity to correct my mistake with this final project. And also, I very, very much enjoyed your class, so thank you so much for that. I also found a website that would allow me to screen share and have my picture in it, so I hope that it works and goes through like it should. Hi, my name is Lauren Espinoza, and this is my presentation on the sustainable solutions to coastal erosion. First, we're going to start off by what is coastal erosion. According to climate.gov in 2019, coastal erosion is a process by which local sea level rise, strong wave action, and coastal flooding wear down or carry away rocks, soils, and or sands along the coast. As you can see on the graphic to your right, types of coastlines that can be formed include beach, cliffs, caves, arches, and stacks. Now, these landscapes are met with nonstop wave action and tectonic forces that are sculpting these different features. This change can be very slow and gradual, or a coastline can be drastically changed by one intense storm surge. Coastal erosion encompasses a solid combination of both anthropogenic and natural phenomena, which impact virtually every coastline. However, the extent and severity of the problem is worsening. This is because current global sea level rise is happening with climate change. Coastal erosion is a result of strong currents, coastal flooding, and higher sea levels, which are responsible for coastline retreat and beach erosion because of long-term sediment loss. Here are some visual impacts of this concept. As you can see, infrastructure like roads and houses are being harmed by this. Now we're going to take a look at some of the factors that influence coastal erosion. So first we have the coastal processes and the erosion rates. Coastal processes, or the types of erosion that can occur, are hydraulic action, solution, abrasion, corrosion, and attrition. The erosion rates are affected by the hardness of sea-facing rocks, which is controlled by the rock strength and the presence of fissures and fractures in the cliffs. This has to do with hydraulic action because air becomes trapped in these cracks in the rocks and causes them to break apart. In addition, we have the beach width and height, the coastal slope, wave energy as well as tides and currents, and onshore and offshore winds. The image at the bottom shows where all of these are taking place. Next, we're going to take a look at the 3 E's of sustainability in coastal erosion, starting off with the environment. As of 2017, 70% of coasts worldwide have been impacted by erosion. This encroachment of coastal land by rising sea levels have destroyed beach biodiversity and the ecological balance of the environment. This devegetates the beaches and cliffs because sand and soil particles are displaced. Increased movement and erosion is directly related to low soil fertility and the ability to sustain a biodiverse ecosystem. The image on the bottom shows this occurring. Equity. With coastal erosion visually impacting infrastructure on the coastline, it is important to understand how it changes the community as a whole. Coastal management should treat each community with the same importance aside from affluence because the origin of these issues include the beach as a public good. The decisions behind beach erosion control should include voices from the public to ensure fair and just solutions for all communities. The last E of sustainability is economics. In the United States West Coast alone, roughly 500,000 people and $100 billion worth of coastal property are at risk during the next century. In highly developed coastal areas such as the San Francisco Bay and Puget Sound, hundreds of millions of dollars are being spent on restoration of nearshore ecosystems. These protect shorelines from erosion by waves and provide habitat for socially and economically important species, which goes back to our environmental aspect. If you scale these numbers to a global level, it becomes an imperative issue to solve. The economic effects of coastal erosion depend on the erosion rates, property positions, values, and lastly, the construction costs. Now, the economics of coastal erosion is a very difficult and multi-step process because each coastal community is very unique. In many cases, the local government will take on a restoration project because increased visitation is attributable to improved beaches and will benefit the local businesses. With this local economic stimulation, a community can meet the guidelines for a public beach replenishment project and receive a federal subsidy that amounts to 50% of the project costs. After talking about restoration projects, we're going to move on to look at what those mean in terms of sustainability. Proposed sustainable solutions. I ordered the solutions in order from most sustainable to least sustainable, and then we're going to dive into what those mean after. First, we have non-structural. Any coastal erosion control strategy that does not involve man-made construction or other physical measures, but is based on good practices, policies, and education aimed at reducing anthropogenic and natural impacts. Next, soft engineering is shoreline erosion mitigation and control measures based on soft methods, namely sand, pebble, or gravel fill. This includes beach nourishment and vegetation. And as you can see on the image on the right, that is after shoreline vegetation work in Hawaii back in 2015. And lastly, the least sustainable solution proposed is hard engineering. This is control approaches based on the construction of man-made structures such as seawalls and breakwaters. And finally, to non-structural solutions, which is the most sustainable options to combat sea level rise, and this includes practices, policies, and education. Though coastal erosion is a natural occurrence, the rate and severity of its harm on our environment and economy is exacerbated by rising sea levels. Rising sea levels are due to climate change because of melting ice caps and an increasing number of tropical storms. In order to combat the increasing carbon emissions in our atmosphere, we need to examine steps on a personal, state, and global level. According to NOAA, on future pathways with the highest greenhouse gas emissions, sea level rise could be as high as 8.2 feet above 2000 levels by 2100. Actions that can be taken to reduce carbon emission include, but are not limited to, buying and shopping locally, switching to electric-powered vehicles, supporting green companies, eating a low-meat or vegetarian diet, and etc. Looking further to local and national governments, it is crucial to educate yourself so you have the ability to teach others about this issue, speak out for yourself, and speak up for your planet. Another important thing to remember is to vote for candidates which implement policies that you support in terms of environmental justice and sustainability. And next, we have soft solutions to coastal erosion, which is second most sustainable next to the non-structural. So with these soft engineering methods, the natural asset of the beach and cliffs will be protected and maintained for future generations to use, while implementing natural, eco-friendly products. One company that I found called GII Works sells coconut fiber walls and earth barrier walls, which are both sustainable solutions for these coastal restoration projects. Other examples include beach nourishment, cliff stabilization, dune regeneration, creating marshland, and manage retreat or coastline realignment. And both the images on the bottom are examples of soft solutions to combating coastal erosion in their beach communities. And that is it for my presentation. I have my works cited on the next slide, and feel free to contact me if you have any questions about anything in my presentation. Thank you so much again, and I hope you enjoyed.